F, we have G. You'll also learn that negatives are better than radicals, because radicals teach you fractions, and then you have to do fraction work, right? People don't like. So you learn to like things better or worse. You learn to like negative exponents because it's not so bad. Okay? So F prime equals 6 goes away. T to the negative 2. What is that? Negative 2. T to the negative 3. Please don't write it as a negative 1. That is not subtracting 1, that's adding 1. Okay? G prime is what? 80 T to the 9, 15 T squared. Okay. So I told you for today we're going to do F G prime plus G F prime. This is what I showed you before. So G prime of X, make sure you have it written like that because that shows you that you found the derivative, correct? The first derivative. So F is 6 plus T, or T to the negative 2, times G, which is 80, G prime, sorry, 80 T to the 9 minus 15 T squared, plus G, which is 8 T to the 10 minus 5 T cubed, times F prime, which is negative 2 T to the negative 3. Okay? This one isn't too bad because we're adding exponents when we multiply. We just might be adding a negative. Okay? So, we are going to get 6 times 80. What's 6 times 80? 480 T to the 9. 6 times negative 15. Negative 90 T squared. And then T to the negative 2 times 80 T to the 9 is 80 T to the what? 7. And then T to the negative 2, and then negative 15 T to the 2 is what? Yes, negative 15 T to the 0, which we're just not going to write. Okay. Because T to the negative 2 and T to the 2 just cancel. Okay? Then we have 8 times negative 2, so negative 16 T to the 7, and then positive 10 T to the 3, T to the negative 3 is T to the 0, so it goes away. Yeah? Nothing crazy. Okay, then we collect like terms. So we get 480 T9. 80 minus 16 is 60 what? 64 T7. And then minus 90 T squared. And then what's negative 15 plus 10? Negative 5. Is there anything I can take out of all of them? The answer is no. Okay? We need to get power or product rule down really well when it's these basic ones, because these are actually the basic ones. But we're going to end up having in them is chain rule ones. So like right now, I've only ever given you like a bracket and a bracket. Right? So it would be like 2x plus 1 times 3x minus 2. But what will happen later is we're going to get 2x plus 1 squared times 3x minus 2 to the 4. And then we have to do chain rule to actually do the derivatives of those. Because you can't use power rule to do f prime, g prime when there's a squared or a cubed on it. You have to do chain rule. Okay? It's not that much harder. Yeah?
If you don't give your answer and you're just sending proofs, that's fine.
Yeah. One. I'm going to label it 3. I realize I labeled them different numbers, but it's the third one I did. So, what do we have to do in order to find a derivative whenever I'm given a radical? Whenever you're given a radical, you have to do what with the square root? Convert it to an exponent every single time you find a derivative. So if you're ever like, hey, Mrs. Lepp, when should I never turn that to a rational exponent? When I'm doing derivatives, I would say never. Always turn it to a rational exponent. Because you're going to have to use power rule somehow. Even in a chain rule, you use power rule. Power rule comes up all the time. It might be embedded in the rule of finding a chain rule, but you're going to have to do it. And the only way we can do that is if we actually have it to those proper powers. So we're going to have y equals x minus x to the half times x squared plus x to the half. Okay? And you notice how I didn't write y prime? Because I haven't found y prime. I just rewrote y in a different way so that I can actually do the derivative of it. Yeah? Okay. So this is f. This is g. What is f prime?
1 minus 1/2.
Yeah. Okay, table, control yourself. So we have f equals 1 minus 1/2 x to the negative a half. G prime is 2x plus 1/2 x to the negative a half. Now guys, if I ask you for the tangent slope, would you do anything different? No, the tangent slope is the first derivative, right? Same thing. If I ask for the tangent slope at a specific x, you would just find the first derivative and plug that x in, right? No different from there. We agree? Okay. So y prime equals f times g prime plus f, or f times g prime plus g times f prime. And product rule is awesome because it has a plus sign in between it, so the order doesn't matter. You literally have to put one with the derivative of the other plus the other with the derivative of the other. You know what I mean? Like, so if it's f, it's g prime, plus g, it's f prime. If it's g, it's f prime, plus f, it's g prime, right? Like, it's with their opposite derivatives. So you don't really have to memorize the formula for them because it has a plus sign. Okay, let's do some distribution. So we're going to get x times 2x is what? 2x squared. 1x times a half x to the negative a half. 1 times a half is a half. What's x to the 1 times x to the negative a half? When I add 1 plus a negative a half, you get a half. Yeah. And then here we get negative 1 times 2 is negative 2. What's x to the half times x to the 1? What's 1 plus a half? 3 halves. And then our last one is negative 1 x to the half times a half x to the negative a half. Negative 1 times a half is negative a half. What's x to the half times x to the negative a half? What's a half plus negative a half? 0. So that'd be x to the 0. Do I need to write that? X to the 0 is just a 1, so it goes away. Okay. Then plus x squared times 1 is x squared. X squared times negative a half x to the negative a half. So this is going to be 1 times negative a half is negative a half. X to the 2 times x to the negative a half. We have to make common denominator, right? So we could go x to the 4 over 2 times x to the negative a half. Gets me x to the 3 halves, right? And then I have x to the half times 1 is x to the half. And then I have 1 times negative a half is negative a half. X to the half times x to the negative a half is x to the 0, so it's gone. Yeah? Okay, let's collect like terms. So we have 2x squared plus x squared, 3x squared, right? Then we have a half x to the half and 1 x to the half. So what's 1 plus a half? 1.5, correct?
Yes.
Which is 3 halves in fraction. 3 halves x to the half. And then we have negative 2 x to the 3 halves, negative a half x to the 3 halves. So what's negative 2 plus negative a half? That's negative 2.5, correct? What is 2.5 as a fraction? Negative 5 halves. So often I'm like, leave it be a decimal, then convert it to a fraction in your head, because it'll often come out as 3 halves or 5 halves, 1.5 or 2.5, 2.57 over 2, right? And then negative a half and minus another half, negative 1. Done. Then we have 4. Yep. You can 100% convert it back. We'd have 3x to the half plus 3 root x over 2 minus 5 root x cubed over 2. Okay, my fourth one. Does everyone have that? Okay, the fourth one is h of x equals root x bracket 2 minus x squared plus 5x4. So every single one we did, we could have expanded and did power rule, correct? We 100% could have done that. And on a test, go for it. If they're like not squared or cubed, expand and then do power rule. Absolutely. But we're practicing product rule because majority of the time, product rule will not be like this, where you can expand and do power rule. So we're practicing with more basic things so that when I throw in a chain rule or I throw in a trig function, it's not that bad. To be blatantly honest, trig functions have people have heart palpitations because of trig. I think it's been like 30-1 killed some trig souls. But trig in calculus is not bad. You just memorize like sine, the derivative of sine is cos. So when you get a sine x, when you do the derivative of it, you replace it with a cos x, right? Seriously. Okay, so it's not like proofs and verifications and stuff like that. Okay? All right. So the first thing we have to do is always convert our radicals to rational exponents. So this is x to the half. And it's 2 minus x squared plus 5x to the 4. And like I said, we could distribute it and do power rule, but that's not the outcome we're practicing. So this is f, and this is g. F prime is going to be 1/2 x to the negative a half. And g prime, the 2 goes away. Negative x squared gives me negative 2x. And then plus 20 x cubed. So, h prime of x equals f, which is x to the half, times g prime, which is negative 2x plus 20x cubed, plus g, which is 2 minus x squared plus 5x to the 4, times f prime, which is 1/2 x to the negative half. All right. So we're going to distribute. Positive 1 times negative 2 is negative 2. I always do my coefficients first, then I do my variables next. It's not as overwhelming. And then x to the half times x to the 1 is a half plus 1, which is 1/2. What's 1/2 as a fraction? 3 over 2. Plus 1 times 20 is 20. X to the half and x to the 3 is x to the 3.5, right? Which is what? 7 over 2. Plus 2 times a half is 1. X to the negative a half, because it didn't have a variable. And then negative 1 times a half is negative a half. X to the 2 times x to the negative a half. X to the 2 times x to the negative half. If I ever get a little flustered, which might happen when you have a positive and a negative, write them off to the side. Right? What's 2 plus negative a half? Well, that would be, what's 2 plus negative 0.5? 1.5, correct? So this would be x to the 1.5. What the heck did I just write? X, I don't even know the X looks like an alpha. X to the 1.5. And what's 1.5 as a fraction? 3 over 2. So can we start with a decimal, move to a fraction if it's easier for our brains to handle it? Absolutely. Yeah. X to the 3 halves. And then 5 times a half is 5 halves. X to the 4. X to the 4 times x to the negative a half is 4 plus negative 0.5. So that's 3.5, which is x to the 7 halves. Okay, well, let's flip like this. So, 20 plus 5 halves. So we need to do 20 over 1 plus 5 over 2, right? Is the same as 40 over 2 plus 5 over 2, which is 45 over 2. And I always practice them without my calculator because you don't know what your prof's going to do. Okay, so we get 45 over 2, x to the 7. Minus 2 plus negative a half is negative 2.5. What is that? Minus 5 over 2, x to the 3 halves. And then we get x to the negative a half. I just wrote it wrong. Got it. And then if we wanted to write it as a radical, we'd go 45 root x7 over 2 minus 5 over 2 square root of x cubed. And then that would drop to the bottom, square root of x.